Hey everybody, welcome back. This is part 2 of the Introduction to Geometry Nodes tutorial. This discussion will center around instances and points. Be sure to go back and watch the first part for information about the Geometry Nodes workspace, creating and modifying geometry nodes, and creating meshes and modifying them in Geometry Nodes. In part 1, we demoed a use case of instance on points with our random cubes. Now let's talk a little bit more about instances and points and their relationship. Instances are basically copies of geometry, whether a primitive created in Geometry Nodes or a pre-made mesh that has been imported. Instances are lightweight and do not significantly increase memory usage or computation time, since they share a single data block, which is defined prior to connecting to the instance socket. So the geometry is duplicated, but they are rendered as individual objects. Points are the smallest unit of geometry. Points are similar to single vertices in that they have no visible mesh, but rather represent a single point in our 3D space. They are often used to distribute objects, such as in our instances on points example. Points are essentially the foundation for placing instances, and we'll take a look at some additional examples now. In this example, we are using a grid to create our points, but let's change this to a different type of mesh. Let's change this to an icosphere. We can increase our subdivisions to see more instances. Let's open our viewer by using Ctrl-Shift and clicking our icosphere node. Then we can plug our random value into the value socket of the viewer. We can see black and white displayed on our icosphere now. The white values represent true, and the black values represent false. This is similar to Boolean values in programming, and you can think of white as a 1 or true value and the black as a 0 or false value. These values determine whether or not that specific point will receive an instance. Let's slide the probability up and see how this changes the selection. We can also change the seed value if we don't like the pattern of points. The viewer can be a valuable tool when trying to debug a Geometry Nodes modifier, but let's get rid of it for now, and we'll look at another way for spawning points. We'll add a Distribute Points on Faces node. This will take the faces of your geometry and randomly distribute points on them. This is our icosphere, but let's see what we get when we plug in our grid. This node also has values for density and seed that we can adjust. Additionally, you can choose between random and Poisson disk. Poisson disk will let you adjust the minimum distance between your objects and the maximum density. This can be very useful when you want to avoid instance collisions. For example, if we were instancing cups on a table, it would look very strange if they intersected. Similar to the Distribute Points on Faces node, we can use a Distribute Points in Volume. To use this with any mesh object, we need to first convert it to a volume. We do this with the Mesh to Volume node. If we try using this with our grid, it will give us no points, since grids do not have a volume. So let's try using our icosphere. Let's increase the size of our icosphere, and now we can see that these points have instances. If we use the viewer with our distribute points in volume, we can see that all the points are in the shape of an icosphere. Note that we have adjustments for density in both the Mesh to Volume node and the Distribute Points in Volume node. Now we'll look at another way that we can create points for our instances, and that is with a points node. Initially, the count will be set to 1. Let's remove our random selection and bump the count value up. We aren't seeing any additional instances as the count is increased. This is because each one of our points is getting created at the position 0, 0, 0, as we see here. Let's randomize that so we can see multiple objects. That's a little better, but everything is still very cramped. That is because the current min and max ranges are specified as all zeros to all ones, which means that our x-axis value will be between 0 and 1, and likewise for our y and z axes. So let's adjust these a bit. Let's make the min -5 and the max +5. Now we can see our instances are spread out. Also, if we wanted to restrict an axis, again, let's think about setting our instances on a table. We can just use the same value for the min and max z-axis value, say 1. Let's take a look at curves now, which we can also use to create points. We'll start by adding a curved circle. We then need to convert our curve to points, and we can do that with a curve to points node. We can naturally adjust our radius as needed. We can use any of the curve primitives we like to create points. Another neat thing we can do is use a text string to create curves, using the string to curves node. I'll type in my text here. For our example, we'll use Hello World. Plugging this into the curve to points directly doesn't look great, and it's impossible to tell what our string says, even if it does vaguely represent letters. What we need to do for these text items is to resample the curves, since the points do not occur evenly by default in the text. So we'll add a resample curves node, adjust the size of our text and the size of our cube, and then we can bump the count up on our resample, which defaults to 10. We can see that our W is getting filled more sparsely than the other letters. On our resample curve node, let's change the drop-down from count to length. Now our text is getting proportionally filled. Let's take a look at our instance in more detail now. We've already seen how we can instance primitive geometry And you may have also guessed that we can import our predefined meshes, like our shape object, as an instance too. Let's do that now. We drag in our shape and hook it up to our instance socket. So let's scale these down until we can see them as individual objects and the text becomes clear again. Let's try adding a curve for our instance. Let's go with a curved spiral. If we plug it in directly, we can see the curves, but they will not render anything. Let's use a curved mesh node. Adding that doesn't seem like it's done anything, but that is because we have to supply a profile curve for it to use. We'll add a curved circle here for the profile curve. Now we can see that our spirals have some heft. Let's adjust the radius of our curved circle down to help distinguish our spiral. We can also adjust the rotation of our spiral, the resolution, start and end radius values, and the height. We also have a checkbox to reverse the direction of our spiral. One other thing we can use for our instances is a collection. Let's create a new collection in our outliner and we'll name it Things. Now let's add some simple objects. We'll add a cube, a cone, a cylinder, and a torus. And we'll leave them all at their default value for size, radius, etc. Of course, you can use collections of more complex meshes, but this rudimentary one will suffice for our demonstration. Now let's drag the collection into our GeoNodes window. We'll hook this up to the instance, and we can see, if we turn on X-ray mode especially, that all of our collection objects are being created on each point. There may be some times when we want to do that, but in our case, we just want to randomly choose from the 4 objects. First, we need to check the box for Separate Children. And then on the Instance on Points node, we need to check Pick Instance. This gets us closer, but we can see that it is just repeating our sequence of objects, and each one appears every 4th object. If we want them to be random, we can add a random value integer hooked up to our instance index. We'll leave the min value at 0 and set the max value to 3, since the indexes are 0-based, meaning that counting starts at 0, and our 4th object will have an index of 3. So now that we have our Hello World message made up of instances of objects in our collection, let's round this out by adding a new material. Our random color doesn't work so well for our collection, since all of our objects have differing numbers of vertices. First, let's head over to the shader editor and create a nice emissive material for our shapes. Let's go with a neon blue. We'll copy the color down to the emission color, bump up our emission strength, and we'll name the color blue. Now let's head back over to our Geometry Nodes editor and edit the Set Material node we added previously. We can then use the drop-down here to select our blue color. Any existing object that we bring into Geometry Nodes, such as our collection or our shape, could have predefined materials that would show up by default without a set material node. But any geometry created in the nodes themselves will have no material without a set materials node. One last really important node we should look at is the Join Geometry node. This lets you join together multiple objects into one output. Let's run our resampled curve into a Curve to Mesh node. And then add a curved circle for the profile curve. And turn our radius down to 0.01. Now we have a solid line running through our objects. Let's take a look at our node editor now. We really should tidy this up a bit. First, let's remove all of the nodes we are no longer using. Getting rid of these reduces the chaos a lot. Now let's organize our sections. Let's group our input section of string to curves, resample curve, and curve to points by using Ctrl-J to join them. Now we can add a caption to our frame by using F2 and then typing a logical name. In this case, we will use the name input, or you could use text or any other descriptor that will help you logically remember what you put there. Next, let's join our collection info, instance on points, our random value for index, and our realize instances, and label it instancing. The labels are just names and don't matter at all. You won't need to reference these names from anywhere else. We could name it Fred if we wanted, but that wouldn't necessarily be intuitive. We can end up with a large and complex collection of nodes, and it's ideal if we organize along the way to help maintain readability. Let's join our curve to mesh and curved circle that we are using to create our text line and name that to text operators. You can add spaces to your names if you like. I am in the habit of leaving them out, but this is a matter of preference. Now we'll take our join geometry, set material, and group output nodes and join them with the label output. You can see that this cleans up our space quite a bit. One other thing we can do to simplify our node setup, make things more readable, and allow for code reuse is to put items into a node group. Let's highlight our text operators and use Ctrl-G. Now we can see that this has moved them into a node group. We can get to our previous nodes by hitting the Tab key. Now let's give our node group a name. We could go with text operations, but really it's more of a curve to mesh operation. So let's name it curve to mesh. Let's add a cylinder, a mesh to curve, and then copy our node group. Or we can find it on the Add menu under Group, Curve to Mesh. We can also see all of the other geometry nodes we created here. This concludes our instances and points discussion and part 2 of the series. In part 3, we'll complete a sample project that will be a simple landscape that will demonstrate easy ways to instance objects in a scene. There's so much more that I'd love to get into here, but I don't mean this to be an all-encompassing tour, but rather an introduction. I will probably make some more videos that are deep dives into specific things we can do with geometry nodes, so be sure to like and subscribe so you don't miss that content. If you have any questions, be sure to leave them below. and I'll see you in part 3.